I've only got 5 minutes. Hi, everybody. My name is Tim. I'm here to talk a little bit about the evolution of what we call our API machinery within Kubernetes. Everybody, please note, this talk is very forward-looking. I'm going to say things that sound insane. They're not true. They will be true eventually. Everybody knows what a TPR is, yes, right? OK, good. Third-party resources. Once upon a time, there was an idea that Kubernetes would grow, and it was going to grow a whole bunch of new features, and we needed a way for people to prototype those new features. So we built, Brendan Burns and a bunch of other people built this idea of third-party resources. You could plug in a new API type into Kubernetes, and it was really super crappy, but it was good enough. And it lets you capture the Kubernetes API style, build your thing like you would build a Kubernetes API, and then prototype and prove that your idea was actually worth doing. It was very limited, though. There was no schemas, there was no validation, there was no defaulting. It was really second class. But it gave birth to the operator pattern. Everybody's heard about operators, right? It's sort of the thing. So people started creating really interesting operators. Operators is it's a software robot that runs in a Kubernetes cluster that manages something. Usually it's a stateful application, but it could be anything. People started to use it for really interesting and clever things. They were managing external systems. They were linking up to other applications. Driven by declarative APIs, just like Kubernetes, actuated asynchronously by controllers, just like Kubernetes. It was a really powerful pattern. So they became a little bit more native. We decided we're going to take this idea of TPRs, which eventually became CRDs, custom resource definitions, and we're going to make them a little bit more native. And so we added this concept of admission control. Admission control means on the way into the system, I'm going to do something to you. I'm either going to say, no, you're not allowed to be here because something's invalid, or I'm going to change you in some way. I'm going to apply some defaults. So we added webhook admission controllers. Now, you could add admission control to your own custom resource definition. So you could do validation, you could do defaulting, and you could do it without fiddling with Kubernetes. You didn't need to change a single line of Kubernetes code to produce a resource that sort of feels like a built-in Kubernetes type. And now we have schemas, so you can define schemas through OpenAPI. And you have sort of declarative validation, so you can say this field is an integer and it must be greater than X and less than Y, those sorts of things, right? This covers the vast majority of what people need to do with custom resources. So how do custom resources fit into Kubernetes? Mostly, they're being used for out-of-tree things, operators, add-ons, stateful orchestration. People, you want to create your MySQLs, or domain-specific APIs. Anybody heard of Istio? It's entirely written in CRDs. It usually provides a higher level of abstraction. Another system is called Knative. It's a serverless framework built on top of Kubernetes. More recently, though, we've been using them for in-tree first-party things. Storage snapshots. It's a pretty cool idea. It's built entirely on CRDs, even though it links up with the rest of the Kubernetes system through persistent volumes. Runtime classes is a new way to describe how your machines are being managed. This is all defined through CRDs. CSI, the container storage interface, is again linked deeply into the system, but it's defined in custom resources. And you can expect to see more of this. This is the direction that we're setting for the project through SIG architecture, that all new ideas are coming in as custom resources. The goal here is custom resources are not second class anymore. So let me paint you the vision. Here we go. We built all the way up to this. All new APIs should be CRDs, unless they can't be. And there's a couple of reasons they can't be, but for the most part, all new APIs are CRDs. Eventually, everything is a CRD. I want to take all the bits that are built into Kubernetes today, pods, services, deployments, replica sets, and I want them all to be kicked out. I want them all to be custom resources. I want the API server to be this generic box that you load type sets into. And then anybody can use the Kubernetes API machinery to serve any Kubernetes-style API that they want. We're calling this the Kubernetes resource model. It's super powerful. It's a really attractive way to build cloud-native declarative APIs. Now, in truth, CRD is not quite there yet. We're not able to handle some of the crazy, weird crap that pods throw at us. But we're working on it. And in truth, we may need to simplify some of what we're doing with the built-in Kubernetes APIs, but we're working on it. There should be nothing, literally nothing, that we, Kubernetes, can do that the average consumer of the Kubernetes API machinery can't do. It should be a totally equal playing field. You can see here, we're going to load the type sets into the API server. This is all work in progress. I said this was forward-looking. We're adding stuff like versioning, sub-resources, better validation. This is becoming a project of its own entirely, and I'm done right on time.